Hey guys, welcome back. I hope you're doing well. Today, we're gonna go back in time 14 plus years to revisit my Hack This Site series that I made back in 2008 and talk about maybe new strategies or approaches to some of these missions. Let's check it out. Alright, let's go to Basic 6.
Today we're going to be doing Basic 6. It's not much of knowing HTML, JavaScript injections, PHP, like in the last 5. It's going to be an algorithm. An algorithm is mathematical, logical steps which you use to solve a problem.
Let me think about that for a minute. So I said an algorithm is mathematical, logical instructions that you use to solve a problem. I think my understanding at the time was pretty good for a middle school kid. Now I want to say algorithms are a set of logical instructions that are used to approach solving a problem. Let's actually look up the definition of algorithm. Typically used to solve a class of specific problems or perform a computation. An algorithm is a set of well-defined instructions in a sequence to solve a problem, a set of rules for solving a problem in a finite number of steps. Okay. Let's continue.
Algorithms are used for security and math problems in general. This is our encrypted password right here.
No, I'm going to disagree with that. Algorithms aren't exclusive to security and math problems in general. Based on our updated definition of the word algorithm, we can see that they are a set of instructions that we use to approach solving a problem in a finite number of steps. Let's be careful with our words here.
Our algorithm, which we'll be using, will look like this.
Why?
We need to subtract that from that, that from that, that from that, etc.
The algorithm would be given a string. For each character in the string, subtract the position that the character is at in the string from where that character lives in an alphabet.
F goes to E, that's 1. So we're gonna go E.
Although, I was looking at the ASCII chart here at the uppercase E. So, yeah, I'm nitpicky because we should have gone to the lowercase e in the ASCII chart and subtracted 1. Or, sorry, the lowercase f in that ASCII chart and subtracted 1. So yeah, that's something to be mindful of, I guess. A problem that I'm having with this is, like, how do you know, like, when you see that ciphertext, how do you know that you're just supposed to pull up an ASCII chart and then subtract 0, subtract 1? I mean, I'm spoon-feeding you the algorithm, so that's fine, but for learning purposes, what strategies would you want to employ to try to figure out what the password is from the ground up? What would I do now? I'd maybe take that string and just plop it in a search engine, see what it returns, just gather some information about it. I'd use some Google Dorks with that string to see what results I can get, and maybe make some inferences based off of the data that I get back. Then, depending on, like, the length of the string, I might see, like, oh, is it reasonable to deduce that this is a hash? If this is a hash, can we figure out what hashing algorithm was used to output this checksum? And then, like, if we can identify the hashing algorithm, you know, then there's just a different set of questions that we'd ask from there, so on and so forth. You know, maybe we'd write our own brute forcing script. Like, maybe another strategy is, well, you know, maybe we can detect that this is actually encoded. Well, like, how is it encoded? Is it base 64? If so, we can just easily decode that. And then, like, from there, maybe use statistical analysis to try to figure out, like, okay, like, these are the most common characters. So, yeah, that's where I sit with this right now. Just keep that in mind when you approach this style of a problem if you approach this style of a problem.